Okay, algebra, we're at the end of the chapter, which means we have the review today and tomorrow, and then we'll probably test possibly on Friday is what I'm going to guess. We're going to do half of this review today, and when I say half, I think we're going to go to like the end of problem 16, which I know is the back page, but there's 30 problems, and I want to not have to do so many tomorrow. So we'll see how far we can get with that. Yeah, so let's just jump right in. It wouldn't be a bad idea for you guys to pause this video and try to do some of these on your own before I give you the answers. So just kind of like we would do it in like whiteboard form, you know, where you fill in what you can, and then, you know, if you have problems, we can do those together. Okay, so number 1 and number 2, there's quite a bit of work that you have to do because they want you to add, subtract, multiply, and divide for each one of those. Okay, so I'm going to separate this into like 4 pieces. I'm going to do a grid that looks like this, and we're going to add, subtract, multiply, divide. Okay, so when we're adding f and g together, okay, f is 8x minus 3 and g is 4x plus 5. So this is what the addition looks like. And then all I have to do, sorry, I have a helper here. Will be noisy. Yeah. So when you're adding, all you have to do is combine like terms. So 8 and 4x. Goodness. And negative 3 plus 5 is plus 2. So 12x plus 2, that's my addition, okay? And then when I'm subtracting, make sure you do them in the same order as they give them to you. So the f comes first, and then I'm doing minus g. Okay, now, I always say caution when you're subtracting because this negative needs to get distributed. So minus 4x minus 5, and then you combine like terms. So 8x minus 4x is 4x. Negative 3 minus 5 is negative 8, and that's what my subtraction is. So this is addition, this is subtraction. Now let's do multiply, and then we'll divide. Okay? All right, so multiply. When I'm multiplying those out, I've got 8x minus 3. Well, goodness, sister. Yeah. Hold on just a second. Here. Hold on. Father. How do I get something done? Okay, sorry about that. Hopefully you skipped ahead maybe. So multiply, we're going to FOIL this. 4x plus 5 and FOIL. I'll go through this a little bit faster. This is 32x squared. 8x times 5 is 40x. Multiply the insides would be negative 12x, and then negative 3 and 5 is negative 15. Then I can just put those middle 2 pieces together. So 32x squared plus, that would be 28x minus 15, and there we go. Okay, that's multiply. And then the last one is divide, and so we've got 8x minus 3 divided by 4x plus 5. And we can't, when we're dividing, we can't cancel like these x's because they're trapped. So really the only thing that I can do is just say that that's my solution. And the only other thing is that this bottom, 4x plus 5, we always say the bottom cannot be equal to 0, right? So if I would solve for x, I would subtract that 5 over. 4x can't be negative 5, and then divide by 4. So x cannot be negative 5 over 4, which is like negative 1.25 or something like that. But that's what we need to have for our division. Okay, so the division itself, you can't do anything to simplify it, but you can say what he's not equal to. Okay, this one over here, we're doing, again, 4 of them. So adding, I'm taking x squared plus x minus 6, and adding x minus 2. So I'm just combining like terms. X squared is the only square, so I'm just going to write him down. But then I've got an x plus another x is 2x. Then I've got negative 6 and negative 2, which is negative 8. And there's my addition. Okay. Subtraction, I've got x squared plus x minus 6. He's just chilling. Minus x minus 2. This is the subtraction, but I have to distribute my negative. So minus x plus 2 is what that becomes if I distribute my negative. Then I'm gonna combine like terms. So I've got x squared. I've got x minus x, which is nothing. Those two are just going to cancel. And then I've got negative 6 plus 2, which is minus 4. And there he is. Hey, that's a difference of squares, but you don't have to break him down anymore. Even though he's a difference of squares, you don't have to break him down. So this was add, subtract, multiply, divide. Okay? All right, in my multiply, ooh, gross. X squared plus x minus 6, and then x minus 2. Okay, I've got to FOIL this. So I'm going to take x squared times this guy and x squared times that guy. That's what I'm going to start with. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Then I'm done with the x squared. I'm going to start with the x, and I'm going to multiply him through. So that's plus x squared minus 2x. Then I'm going to go to the last piece, which is negative 6, and I'm going to multiply him through. So minus 6x plus 12. And now I combine my like terms. All right, so x cubed, he's got nobody to go with. Whoop, cubed. So I'm going to cross him off. These two, negative 2x squared plus x squared would be negative 1x squared. You don't have to have the 1 there if you don't want to, but I'm going to put him there. Minus 2x minus 6 is minus 8x, and then I have plus 12. So that is my multiply. That was kind of ugly. And then the last one is divide. So I've got x squared plus x minus 6 divided by x minus 2. Okay, now I can't cancel this x with like this one because they're trapped. But here's the tricky part. This one's kind of a weird one. This guy is a simple trinomial. And what I'm doing is I'm trying to multiply to get 6, but when I add them, give me this number, which is 1. So he will break down into like x plus 3, x minus 2, right? Those are my two numbers. 3 times 2 is negative 6, and 3 minus 2 is 1. And then I've got x minus 2 on the bottom. And look at that. My x minus 2, because that's a whole piece and that's a whole piece, those will cancel. So I just have x plus 3 as my final answer. Okay, and I don't have to say what x can't be. I just put x plus 3, and that is all. My division actually came out kind of nice. Okay, all right. Whew, that was a lot. Add, subtract, multiply, divide. Okay. All right, 3 is going to be a long one. 4 and 5 might be a long one. And then as soon as we get to 6, we might be into some, well, I don't know. This whole page is a little long. We'll see. We'll see. We might not get to that backside. Okay. All right. They want us to do F composed of G and G composed of F if they exist. Okay. So I'm going to do a table of F composed of G. And then I'm going to do a table of G composed of F. Okay. So here's the deal. When we do this, we start with the inside one. So if I'm doing F composed of G, the inside one is going to be my G, okay? And G is this guy. So where I start on the G is with the X's, 6, 2, and 9. 6, 2, and 9, okay? All right, again, that was my inside guy right here. G was the inside, so I start with those guys. All right, now, blankety miss it. These are really fast. If I plug 6 into the G table, out pops 0. Now I want to take that number and I want to plug it into the F table. Well, 0 is right here. That becomes 9. So 6 is going to become 9. 6 became 0 and 0 became 9, so 6 becomes 9. And that's how it works with both of them put together. It's like $6 reduces down to $0 with the sale, but when I apply the coupon, it then turns to $9. Whatever, it's like applying the sale, applying the coupon, okay? 2 became negative 1, and negative 1 becomes 2 again, so that's 2. 9 becomes 5, and 5 becomes 6, so 9 becomes 6. That's that, all right? The second one that I have to do is G composed of F, so I'm going to start with my F's. And F's are these guys, and I start with the X's. So I do negative 1, and 5, and 0, okay? All right, now I look at those numbers. Negative 5 becomes 2, and 2 becomes... What did I say? Negative 5. Negative 1 becomes 2, and 2 becomes negative 1. So negative 1 becomes negative 1 again. Okay. Next, 5 becomes 6, and 6 becomes 0. So 5 becomes 0. Last one is 0 becomes 9, and 9 becomes 5, so 0 becomes 5. And those are my two tables for F composed of G and G composed of F. You could write those out as an ordered pair, like this is the ordered pair 6, 9, but you don't have to. You can just leave them in table form, and that will work, okay? All right, now they want us to take these two. So here we were doing composition. So that's that open circle again, right? Sometimes they write F composed of G. Instead of it looking like fog, they'll write it as like this with parentheses where the G of X is like stuck inside of the F of X, right? Okay. And they're doing the same thing down here, but instead of using ordered pairs like they did up here, we have functions that we're doing, okay? So I'm going to separate this into pieces. We have F composed of G, and we have G composed of F, okay? So here, G was my inside. That means this guy is going inside here. So it's going to replace this X. This X is like gone, and that stuff's going to get shoved in there. So 2x plus 7, like this guy is taking the place of him. I've got negative 5x minus 1, and that's going to be in that spot. All right. Then the last thing that I have to do is multiply 2 through. So I've got negative 10x minus 2 plus 7, but then I can combine those two. I guess that's not the last step. Negative 10x plus 5 is what he will simplify to be. Okay. Now here in this one, the difference is the F is going into the G. So I'm going to erase. And this stuff is going to go in right here. It's going to delete this X out, and that stuff's going to get shoved in his place. So negative 5x minus 1, but then 2x plus 7 is going to go in his spot, okay? And I'm going to distribute that through. So I've got negative 10x minus 35 minus 1, all right? And these two can go together as negative 10x minus 36. So there is that. Okay. Oh man, we got another one over here that we got to do. Okay. So this one, if we do F composed of G and G composed of F, here the G is going into the F. We start with the inside. So this guy is going in to here. It's going to get replaced with that guy. Not the square stays. So instead of it being x squared, it's going to be negative 4x squared. Oh, but don't forget the minus 1. So x squared minus 1. All right. This one's a little tricky. Negative 4 squared means negative 4 times negative 4, which is 16, and x times x, or x squared, which is x squared. So that's what negative 4x squared is. And then I have minus 1. He's just chilling. I can't put those together, so that's it. Okay. This one, I'm going to go the other direction. I'm going to take the F and put it into the G. So this stuff is going into here, and it's going to cross that X off. So I've got negative 4 times x squared minus 1, and I can distribute my negative 4 through. So negative 4x squared, and then plus 4 is what he will be, and that's all that I can do. Okay? All right, these next ones are really fast. They are doing, look at the difference between F composed of G of X and F composed of G of negative 2. Okay, it looks similar, except instead of leaving the X, we're plugging negative 2 in, and it makes all the difference in the world. Here, when it's F composed of G of X, we'll just get in, we'll get an equation as a number. Here, as an answer. Here, we're going to take negative 2 and we're going to plug it into G. Like that's my sale value, and then I'm going to plug that number into my F function, okay? So negative 2 is going to go into G. Negative 2 goes here. That is going to become negative 11. I'm going to take that now and plug that into F. Oh, we've got 2 places to plug into F. Negative 11. So I've got negative 11 squared plus 2 times negative 11. Negative 11 squared is 121. And this is going to be minus 22, so like 99, I think, is the overall final answer. Okay, not negative 11. That was just part of, like, to get to the answer. Okay. Oh, shoot. Then they want me to do another one. They want us to find G composed of F of 3. So 3 is going to go in, but he's going to go into the F function first. So I'm plugging him in here. 3 squared plus 2 times 3. 3 squared is 9, 2 times 3 is 6, so that is 15. Now that 15 is going to go into the G function, which I've covered up here. So 15 minus 9 is going to be 6. So overall final answer is 6. 15 helped me get to that point. So first answer is 99, second answer is 6. There's 2 answers to each problem because there's 2 things that we need to plug in. Okay. All right. Let's do F composed of G of negative 2. And then let's do G composed of F of 3. Okay, so here again, we're plugging -2 into G. -2 goes into here. So I have like 3 minus a -2, which is 5. Now I'm going to take 5 and plug it into F. So I've got 5 times 5 plus 4. This is 25 plus 4, which is 29. So final answer, 29. Okay, and I'm going to cross the 5 off so we don't think that that's the answer. All right. Next one, we have 3 to plug in. We're going to plug that into F first. So 5 times 3 plus 4. This is 15 plus 4, which is 19. And then I'm going to take 19, I'm going to plug them into G. So here, 3 minus 19, that is going to be -16. That's my final answer. Okay? All right, so plug in different things in. All right, all right. Oh, heavens. All right, find the inverse of each function, then graph the function and its inverse, okay? So for 8, 9, and 10, there are 4 steps to finding the inverse. Number 1, you take the f of x and it changes to y. Number 2, the x and the y switch places with each other. And then the third step is solving for y. This is the hardest step or the longest step. And then number 4 is we take the y and we rename it f inverse of x, which kind of looks like f to the -1 power, okay? All right, so a lot of people will do step 1 and 2 at the same time. F of x becomes y, and then I switch them to x. The y becomes x and the x becomes y, so I've got it like this. And then I have to rearrange and solve for y in step number 3. So I'm going to get this guy by itself. So I'm going to add the 1 over first. X plus 1 equals 2 over 3y. And then I have to divide by 2/3, but rather than doing that, I'm going to multiply by 3 over 2. I multiply this by 3 over 2, and I'm going to distribute him through. So I've got y equals 3 over 2x plus 1 times 3 over 2 is 3 over 2. And 3 over 2, by the way, as a decimal, I'm going to put my decimal here, is 1.5. Okay, so last step, I guess, I'm going to move my y over to this side. This is f inverse of x is what I'm going to rename him. And I'm going to put the equation on the right side because that's how I like to write it. 1.5. Okay, now they want us to graph this one and this one on the same graph. So I'm going to graph the first one, the original one in blue. And to graph that, that's a linear function. I'm going to start at -1, and I'm going to go up 2 and over 1, 2, 3, up 2 over 3, or I could go down 2 and to the left 3. And this is what my linear function is going to look like. Something like that, okay? The second one I'm going to graph in pink, and that one I have to start at 1.5. So right there at 1.5. From there, I'm going to go up 1, 2, 3. I'm at the half point, and over 2, 1, 2. Or I could go down 1, 2, 3, and over 1, 2, and he will look like this. Okay, and those are 2 linear functions. I know that I did it right when those 2 are reflected across one another. Okay, so it's like I've taken this guy and I flipped him over and vice versa to get that. And those 2 are inverses. Okay, so that's how you do the inverses, to do those 4 steps. Okay, I'm going to cut it down a little bit on you. Let's skip number 9 and we'll just do number 10. Okay, and we'll do the same thing for the bottom one. Maybe we'll skip 12 and we'll go just 11 and 13. Okay, just because these kind of take a little while. All right, so step 1 is switching this to y. Step 2 is becoming like the x becomes y and the y becomes x. All right, now I have to solve for y. So I'm going to add the 2. I've got x plus 2 equals 1/4 y. By the way, if I'm going too fast, please pause the video and catch up if you need to. I'm going to multiply this by 4 to get rid of the 1/4. I multiply by 4 over 1, right? Multiply by 4 to get it to go away. That's by multiplying by the reciprocal. We've got y equals, if I distribute my 4 through, I've got 4x plus 8. Ooh, this is my inverse. So I've got f inverse of x equals 4x plus 8. I could have written that backwards, but that's okay. So there's my inverse. My original was that one. So if I graph my original, I'm going to go off the chart. I'm going to go by 2's. So I'm going to say this is, 2, 4, 6. You do whatever you want, but I'm going to go by 2's. -2, -4, -6, -2, -4, -6, -8, +2, 4, 6, 8, etc. Okay. All right. My original guy, I'm going to start at -2, which is here, and I'm going to go up 1 and over 4. Now, you might be wondering, like, but didn't you go by 2's? So you have to go up 1 and over 4. Okay, up 1 would be here, and over 4 would be here. But guess what? My next one, up 1 and over 4, 1, 2, 3, 4, is going to be at that same dot. So it doesn't matter when I've reduced my scale. If I go up 1, which would be a half of a box, and over 4, which would be 2 boxes, or up a whole box and over 4, right? So down 1 over 4, I could do that as well. And here is what my original guy looks like, okay? That's what my original function is. The other one is up at 8, and then, oh heavens, I've got to go up 4, up 1, 2, 3, 4, and over 1. So he's going to be over here like this, right? Or I could go down 1, 2, 3, 4, and over 1. Down 1, 2, 3, 4, and over 1. So here is what he looks like. Now let's check by just using our little eyeballs to see, is he reflected across this magical dotted line? Yep, looks like it. So these two are inverses of each other. Okay, we found the inverse by doing those 4 steps. All right?
Mommy,
okay.
I love you.
I love you too. Are you ready to go to bed?
Yeah.
Okay. Why don't you go lay down? And I'll come tuck you in a second.
I want to lay here.
Okay. You lay right here, and I'll finish, okay? All right, determine whether each pair of functions are inverses, right, yes or no. Okay, so I think it was Dylan the other day. He likes to just start with one function and see, like, does it become the other one? But there's another way of doing this, and this is by, like, doing the composition thing. So F composed of G and G composed of F, and then seeing if it reduces. So what I want to do is I'm going to take this guy, and I'm going to plug him in for X here. So 3 x minus 1, but I'm going to put 1/3 x plus 1/3 in there, okay? And if I multiply my 3 by my 1/3, 3 times 1/3 is just going to be x. 3 times 1/3 is 1, and then I've got minus 1. Okay, so like this becomes just 1 on each one. 1x plus 1 minus 1. And then the 1's will cancel, so I just have x as an answer. Perfect, okay? If I do it the reverse way, and the more you do this, the faster it becomes, okay? So if I plug F into G right here, I am going to do 1/3, I'm getting rid of this guy, 1/3 times 3x minus 1 plus 1/3, okay? Now if I multiply my 1/3 through, 1/3 of 3 is just 1x, and 1/3 times 1 is minus 1/3, plus this 1/3 right here. And these two are going to cancel, so I have just x as my answer. So, are these inverses? Yes, they are inverses. Okay, and that's how that works. All right, let's go to number 13 and see what we get here. Okay, so if I do F composed of G, and then I need to do G composed of F. So I'm going to do, the G is the inside one, he's going to go there. So I've got 1/2 times that stuff, this is gone now, minus 10, but I'm going to plug this into here. Okay, all right, now I'm going to distribute. 1/2 of 2 is 1x. 1/2 times 1/10, I would do 1 times 1, which is 1, and 2 times 10, which is 20, and then I've got minus 10. Okay, usually when I put these together, these two would cancel, but it doesn't in this case, right? Like, there's nothing I can do. I mean, I could put these together and I'm going to end up with a really ugly number. But the point is that this is not equal to just x, right? So what that means is I don't even have to do this side because this one is a fail already. And that means that these are not inverses. okay, because the first one fails. It doesn't reduce to just be x, so it fails. Now, why does it reduce to be x? Like, why does it become x over here and x over here? It's because each graph of inverses is reflected across this dotted line, y equals x. Okay, so that's kind of how why coincidentally it reduces to be x. Okay, let's see, do we want to do some more? I know you're shouting at me like, nope, we're done, let's quit. Okay, here's what I want you to do. You try 14 through 19. Okay, I'll let you off. We'll quit for the day, but I want you to try 14 through 19 on your own. We were just doing these on whiteboards the other day, and you guys were like killing it. It was awesome. So try those. Try 14 through 19. We'll go through the answers tomorrow when I come back. Okay.